I'm going to try to define a piecewise function in Mathematica that's the same as the absolute value function. So let me call it f, and we'll use the same syntax we always use for defining functions. F square brackets x underscore colon equals. And now I want it to be a piecewise function, so how can I do this? Well, there's a built-in command in Mathematica called piecewise. And the way we're going to use it, at least at first, is the input to this piecewise. It's going to be a list of lists. So let me first make the outer list. And now what kind of inside lists are we going to have? Well, let me show it to you down here, what the syntax is. Here is piecewise. So this value, think of that as what's the function, and this condition, think of that as should we evaluate this function or one of the other functions. So as an example, let me say that it's f of x is just going to be x if x is greater than or equal to 0. So I do greater than or equal by doing the greater than sign and then the equal sign. And then you can see when I typed in my first number, then it formatted the greater than or equal to symbol to this little thing, but I got it just one piece at a time, greater than, equal to. Okay, now if I hit 0, now it formats like that. So that's going to be my first inside list. So think of that as saying if x is greater than or equal to 0, then f of x is equal to x. And what about the other one? Let's say f of x is negative x if x is less than 0. It also would have been fine to say less than or equal to 0. Both would have given me the correct answer. So I evaluated it. Now let's test it out to see if it works. So let me test it by, how about plotting? So let me try plotting fx with no underscore here, just fx. And then I want to plot it for x from, how about negative 10 to 10. And let's look at it and see how it works. So it looks super strange, looks like a piecewise function, but doesn't look anything like the absolute value function. Hey, here it looks like a parabola, and here it looks like a straight line. So what went wrong? Well, if you were to rewind the video, you would have seen that when I started writing this f bracket x, the letter f here, it was always in black. And that's something you should really be on the lookout for, and it comes up more often when you're defining functions than it does in general in Mathematica. So the way Mathematica works with functions, it has a habit of remembering old function definitions. So just get in the habit. Here I'm going to have two different lines, but in the same cell. I'm going to put a clear f here. So that's like saying, forget the old definition of f, which I secretly defined before I even started this video. And then here is going to be my fresh new definition of f. Okay, so let me evaluate it. Now let me plot it. Now that looks like the absolute value function. So the lesson to take from this is, especially when we're defining complicated functions or when we're defining piecewise functions, get in the habit of making sure you clear the function at first, because otherwise there can be some precedence which makes things confusing. So you might think that when you write f bracket x, that's just going to delete the old definition of f, but it doesn't always work that way. So especially with function definitions in Mathematica, get in the habit of starting it with clear. So the last thing I want to say about how piecewise works, let me change this f here. What if I had, instead of x for my function here, what if I had 2 times x plus 5? And what if here, instead of saying for x less than 0, what if I said for x less than 8? So let me define that. Now let me plot it. So the big thing I want you to notice is that there's some overlap in the conditions I defined. X greater than or equal to 0 and x less than 8. Well, what if I choose x equal to 5, which takes precedence? And it turns out that the way Mathematica does it is whichever one came first takes precedence if there's overlap. So because this said x greater than or equal to 0, and that works for 5, this 2x plus 5 function definition is what's going to be used, not this negative x function definition. So just to convince you of that, let me go down here and test out f bracket 5. So it used this 2x plus 5 definition. It didn't use this negative x definition because 2x plus 5 came first. If I were to write it in the opposite order, okay, let me cut that and paste it over here. And now let me plot it. Now it's different. Now because this x less than 8, because that comes first, then it uses this negative x definition for all of these, and then only when it gets past that, only when it gets past this 8, does it start using the other one.